everybody, today is day 8 and we're going to do a very quick review of the entire unit. I do feel like a lot of you need to review because of the holiday break. It's really been tough. This unit has been really split apart, so I'll do a quick review with you, and then I would encourage you to work on that purple review sheet to the best of your ability and to really be coming in and getting help with the questions that you don't understand on that purple review. All right, so let's go through what we've learned so far. First of all, when we are solving for x and it's down here low, meaning low in the base, when the variable's down here, the way to get that x all by itself is to raise both sides to the reciprocal of this exponent. So we're going to raise both sides to the 1 over 3, because this is 3 over 1. Do the left and the right. On this side, it makes those drop out and just gives you an x. On this side, I'll get 7 to the 1/3, and then that can type right into your calculator. It is a cube root of 7, but you can also do 7 caret 1/3 equals, and it's going to give you an answer. So we'll go 1.9. This is when the x is low. When x is low, raised to the reciprocal. The second kind of thing that we did on that same first day at the beginning, before we even knew what a log was what if the x is not low, but instead the x is up here, up in the exponent? For that, we need to get like bases. So we want to replace the 4 and the 8 with something that equals 4 and 8, but that will have a matching base. So we're going to replace the 4, with 2 squared, and we're going to replace the 8 with 2 to the 3rd power. This 2 right here distributes. That hits that and that. So I'm going to get 2 up to the 2x plus 4 equals 2 to the 3rd. And once I've got that, I drop the bottom 2's and just set the tops equal. 2x plus 4 equals 3. And then we'll solve just the top part, the exponent. It looks like my answer here is going to be -1/2. So this is when the x is up high here in the exponent, you get like bases. You also need to be really comfortable and confident switching between log form and exponential. You need to understand where things go. So I'm going to do a switch without numbers but with just letters. So if I have something like log A of W equals H, and I want to switch it from this log form into exponential, something that would equal it, these are equal to each other, is just writing A raised up to the H equals W. So when you switch from log to exponential, there's no word log anymore. It's this low guy raised up to that exponent equals that. Working in the other direction, suppose we have something like L up to the J equals B. And they ask you to make that into log form. So I've got exponential and now I need log. I'm going to write the word log. The low part is the L of B equals J, because this thing that's over here is the exponent. And then we had this idea of log equations and what we can do to solve. So we had the idea that when you've got a log on just one side of an equation, you're going to switch it from log to exponential. This feels unbalanced. Log is on one side, so let's switch it to exponential form. Again, it would be x raised up to the 2nd power equals 81. That's my switch. Now, obviously, we kind of know the answer is 9 here, but if you didn't know the answer, you would think to yourself, oh, the x is down low. I need to raise to the reciprocal, both left and right. This gives you x by itself. You could put 81 to the 1/2 in your calc and get that. Suppose instead the x is in this spot. Same thing, when I switch it, it'll be 5 raised to the 3rd power equals x. And now it's super easy. I just put that into my calculator or into my brain. I don't have to even do anything. And then the last potential place the x could land, well, what if x is over there? Again, first step is to be able to do the switch. You have to be confident getting out of log and into exponential. It will be 2 raised up to the x equals 32. And then you pause for a moment and say, oh, the x is up high? That's the one where I have to get like bases. 2 to the x equals 2 to the 5th. Drop out the 2's. My answer is x equals 5. In that same unit, we also had those log laws, expanding and contracting. And the idea was if we had multiplication, it's the same as addition. If we had division, whoops, I wrote log of A divided by B, it would be subtraction. And then log of something up to a power is that thing times that. Those are the 3 basic laws, the product law, the quotient law, the power law. And they can ask you to do all kinds of expanding or contracting with those. All right, and then our last day were the log equations. And there were, again, 3 kind of potential possibilities. Number 1, there's no logs anywhere in the equation. It just looks like this. And you might say, well, the x is up high, I'll get common bases. But I cannot get a common base here. Obviously, 2 to no power makes 13, which means this is not going to be an integer. It's going to be some decimal. The only way to get the x out of the top and to bring it down is to add a log into both sides. So we're going to go log of 2 to the x equals log 13. Because it's an equation, as long as I do it to left and right, it's okay. And then this x drops down and is out front because of that power law. So then I get this. And then to get x by itself, we're just going to divide the log 2 over. That drops out, and you would just type this into your calculator. Don't cross out the logs. You really type in log 13 divided by log 2. If you are unsure where that button is, make sure that you ask. So that was possibility number 1. There's no logs, but I just put them in. Possibility number 2 is that there are logs, but they're on both sides of the equation. If they're on both sides of the equation, I can just take them out. So I can put them in or take them out. Again, as long as I do the same thing to both sides, I would just set that equal to that and solve. It's possible that you would have to do some combination of the log laws to get them together first, but in this example, they were already together. And then our last possibility is, well, what if logs are only on one side, not on the entire thing? So let's say I've got log x plus log x minus 3 equals 1. I'm going to apply my log law right here, which says if I've got addition, I'm really going to do multiplication. So I'm going to combine that together, and I will get x times x minus 3, because I'm going to multiply them. I'm going to make one more line which just does x squared minus 3x. And because, again, this has log only on one side, we're going to do what we did today to start, which is switch the form. When log's only on one side of an equation, I've got to switch it to exponential form. And there's no number down here. There's no base. So remember, when there's no base written, it's an invisible 10. This is called a common log. So it's 10 to the first power equals that. And then from there, we're going to solve. Of course, 10 to the first power is just 10. We'll move the 10 over, make a trinomial, and then solve it. From here, you're going to factor, split, set them both to 0 and get your 2 answers. Whoops, that's positive 5 and negative 2. And in this example, the negative 2 won't work because if you go back here to substitute it in, it will reject. So my answer here is just 5. All right, that's it in a really quick nutshell. There were certainly some small little details like the graphing and the natural logs. There are some little odds and ends that you would also need to be aware of. Please work on the purple sheet now for the rest of your homework. Thanks a lot. Have a great afternoon, and we'll talk to you tomorrow, folks.